With our operator algebra now completely in hand, we are prepared to really begin to investigate now what the effects are of these L plus minus operators. So what do these L hat plus minus operators, what do they actually do? So to begin that analysis, let's consider a state, right? We're going to begin with, say, L hat plus or minus. I'm going to act it on one of my pure states, which we've decided to label as y sub lambda m. And I want to see what the properties of this new state are. For example, we could ask, well, what happens actually when I think about the application of L squared to this state? One of the questions that we might ask ourselves is, it's just a question, a conjecture maybe. Maybe, if we're lucky, we will find that this is a pure state of the total angular momentum operator, but maybe with a different total angular momentum, something very similar to what we saw in the harmonic oscillator with our A dagger and our A operators. So the question is this going to give me back some kind of a constant maybe times the original state that I've begun with? Y plus or minus L plus or minus on y lambda m. So let's see what we actually find. So what if we operate with L squared on, okay, I'm going to try to remember not to write my hats. It's become such a habit. So if I'm applying L squared to L plus or minus y lambda m, what I really wish was happening, actually, was that these were in the opposite order from each other. Because if they were, right, then I would have L squared on y lambda m. And I know what that is. That's just some constant times y lambda m again. And I could pull that constant out, and what I would have would be a constant back times L plus or minus acting on y lambda m. Excuse me, which is precisely the type of math that we're hoping to find. Excuse me again. Now, they are not, however, written in that order, but we know how to handle this, right? We can get them in the correct order. Without changing the value of my expression, we can play our favorite trick of inserting the commutator there, which gives us our original term, but it now is subtracting off these two operators in the opposite order. So to restore order to the universe, right, and make my equation still true, I have to add back in the operators written in the other order. So this is a way I can actually just commute the two operators, and this commutator then just represents the cost of carrying out that commutation.